Hello. So I'm Aditya. I was like I'm computer science graduate and I have been working as software engineer for past 1 year. I was recently laid off. I will be doing some stuff today and just for casually I'm live today. First of all, let me explain what is ARC. So ARC, let me tell you the full form first. Abstraction Reasoning Corpus. So this is basically the abstraction reasoning corpus, or you can say database for uh, you can say if anyone solves this like the here is a kaggle competition arc best 2024 and the competition is one who like we are given input of like basically 3 to 4 images and the output for each one of them. After from those 3 to 4 input output images we need to predict the output for the final input given. So this basically this images or this data set is basically like uh, testing the intelligence of system. So it is claimed that Francois Cholet, he claimed that if this is solved by a machine or a computer or any system, it would be the first step towards the AGI, or like this will be the first step towards the AGI. AGI is basically artificial general intelligence, artificial general intelligence and artificial narrow intelligence. Let me first explain what these two concepts are. Artificial narrow intelligence is basically constrained towards the task, only towards the task we are in. And artificial general intelligence is like applying artificial neural network like or deep learning to, or not deep learning or artificial neural network, the AI for the broad use. Suppose I have developed a self-driving car, and self-driving car is running in India. So basically, in India, the rules are to drive from left side, and those are the basic rules. But if the same car is uh, put for driving in America, then it won't be able to drive because the rules in America are totally different. So what AGI is, if we develop a car based on AGI, which is like acting as AGI, then it should be able to drive anywhere in the world by learning the things present in that environment and everything. So basically, AGI should be the system which develops intelligence on the fly. On the fly synthesis is what AGI system is. So I have went through the ARC. I have went through ARC dataset. What it is? Let me tell you the example. Like these images, in the ARC, or these problems in ARC, like literally so easy for humans to solve, but computers have not been able to solve this. Highest accuracy is achieved by like I will go through that paper too, which has used LLM for like there are two possible things which I've done. Let me tell you. So this is basically the task. I will give you example. Suppose so what it is doing is input for this is input and it is generating output like this. For this image we are getting this, for this we are getting this, for this we are getting this. So we need to predict for this. So this is very simple for human to do. Like so this is 12 by 12 grid. Okay, and we do 13 है क्या 1 2 3 4 5 Get it. It will move towards right. Correct. So basically, what it is doing is it is just adding the blocks of the inside box to the diagonal of the outside box. Very clever. This will be correct now. Correct solution. So this is basically so easy for humans. Like there are 400 tasks. These are training tasks and 400 evaluation tasks. So you will find more information about Asia and in this paper of Francis Cholot. Uh, on the major of intelligence. This is a really good paper. Like if anyone wants to like do research in EJ field or something, you should go through this paper. Like this paper describes the uh, what it describes. Like it describes the uh, like if intelligent system is developed, how it would be, and there are some concept like generalization difficulty priors which are like required for an intelligent system to understand, and how intelligent how strength of intelligent system can be calculated, or like what is experience or what is skill. Everything is here. Like uh, it was claimed that uh, if AI solves the chase, or like solves chase, no, like AI is able to beat every person on the world in the game of chess, then we would be at the state towards the AI. But it was like proved wrong, as chess is basically memory based game. Like it does not use intelligence. Like what we do is we develop decision trees, we evaluate the position, and we follow the path which gives the best advantage from that position, right? So like I have read this complete paper. It is a really good paper, and second part of it describes the arc task and why it could be the path towards HI. So I have went through the data set. I had thought about some solutions. Solutions for the arc. Let me first describe you. If you want to do any one more, this was pretty easy. These two is pretty easy. What they are doing is adding corner blocks with blue, the center box with this orange red color, and the remaining boxes with yellow. Basically they are doing this. So what I was thinking was, to solve the arc we need to develop a program which returns the function in which we have the rules for getting the output for given input. Suppose, like what I'm saying is, suppose suppose we have these two inputs, correct? So what we will do is we will pass these two inputs along with their outputs in a function, correct? From that function it will do some analysis, do some calculations, run some programs, run some models, previously built models, everything we need to do. And what that function will return is the set of rules, you can say, or the program, if on which if we run this new input, then it will return the expected output. So basically, if while going through this path, uh, Like I thought of what machine needs to learn, what priors should machine have while solving the task of like R. So first of all, it should understand like traversing the 2D grid in like DFS BFS manner. Like, so this is basically a graph. This is basically a graph with this is basically a graph. So it should understand DFS, BFS, graph traversing. Also some other concepts like what is like mirror image of something, uh, or water reflection image of something. Let me tell you again. Like there are some tasks which have like mirror images in them, or like suppose output is complete mirror image, but some of the boxes are unfilled, and we have to fill them with the proper mirror image. And the mirror image is like from the center of the grid to the left and right. The center is like acting as mirror, and the center line is acting as mirror, and one other half is a reflection of other, mirror reflection of other. So there are some tasks. What I was categorizing is, first of all, let us categorize the art problems into three sets. And these three sets, I think, cover all the problems. Like basically, the input size of grid, like this grid, 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. This is 7 cross 7 grid, right? And also output is 7 cross 7 grid. So there are three basically tasks we can categorize. First is the size of input and output is same. Size of input and output is same. Size of input is less than the output, and third is size of input is greater than that of output. So after categorizing into these three categories, I was thinking was uh, solving these three tasks independently. Like the methods used for all three type of tasks are different. So for example, I will tell you the size, where size is different. Size is different. This size is same. This size is different. Like this is 1 2 3 1 2 3 4 5 6 9 9 cross 3 grid as input, and we are getting 3 cross 3 as output, right? So basically this is the part of this one, and we are getting this as of blue. There are 1 2 3 4 5 6 7 8 8. if we if we consider these three boxes, 1 2 3 individually, then it has 8 blue boxes. This is 6 and this is 6, so 8 is the largest number, so we are getting output as this. Same for here, there are 5 orange blocks and 4 4 4, so we are getting orange one. Same basically, same rule will apply. We will get this as output. I will resize this 3 cross 3. So correct solution. These are basically too simple, but these are hard to interpret for machines. As like as a human brain, we can immediately see that we can divide this into 1 2 3 blocks, and one of the blocks is the output. Same for here, like we are dividing this horizontally into four parts, and one of these blocks is output. But we can understand like why this is output, because the count of blue is like count of blue is like is the maximum in the count of other color than black in these three blocks is maximum, hence we are returning this output. We can understand this, we can count this easily, and we can by intuition we can guess this correctly immediately. But for a program, for a computer, this is not an easy task. Like it is too difficult task for a computer. Like suppose we have n rules for generating an output for the problem where input size is larger than that of output size, correct? So suppose there are n set of rules for computer to generate the answer. It will run through all 10 and test and patterns, and it will match which one is the output we are getting. Also, it is possibility that the end program, the end patterns which we have decided earlier, also the pattern is not in the answers in one of the following. So we cannot predict that what will be the pattern, or we cannot like train the data set on numerous thousands of pattern, 10,000 of pattern, because we don't know what will be the pattern in evaluation set, or like we can't predict what will be the pattern. Basically what we want to do is we want to figure out the pattern while evaluating our problem. So to find that pattern, first of all what we need to do is what we need to do is we need to write a function like what I said at earlier. Let me just open the obsidian. This is another paper which has tried to solve R by using LLMs. So what it has done is, so it has arranged the problem statement as like we are given training set of examples x1, y1, x2, y2, xn, and for each of xi, there is some function which is giving the output yi, but the function is unknown. So we want to know what is the function, right? So what it is doing is it is taking this as training examples, natural language hypothesis. Hypothesis is basically we are telling the LLM to write the rules for generating the function. Like suppose let me tell you an example. I just closed it. Suppose this is basically the task, right? And this is like one of the inputs. What it is doing is it is just doubling. What it is doing is it is it the exactly what it is doing is exactly doubling this thing, completely this thing. नहीं. Let's first count the size: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Huh. The output grid is double the size, and also huh, Exactly. Like there will be some rules, right? Let me tell you. For a simple rule, oh my god, how to generate rule for this? So what this is doing is the shapes which are like having opening like this, like see this and this will turn to pink, this will turn to blue, and these two will turn to red as they are like this line is getting from middle. So this rules what I'm saying currently, like where the one which is taking uh, L curve, L curve, like complete curve, and we are getting a box inside which from three sides we are getting covered. So this could be rule. For these two, we need to write separate rules, separating these two from these two rules. Also for this, like there is not a single like black box which is covered from green by other three sides. So these rules are generated in this paper with the help of LLMs, and they're getting like accuracy around like 33% without human intervention, like no human is helping. Program only 23%, summarized hypothesis 30, and human selected hypothesis 33%, human written hypothesis 45. Human written basically human is writing the hypothesis. So this is the accuracy we are getting, but the thing is this is one of the attempts to generalize LLMs, one of the few attempts to generalize LLMs. uh, what I was doing is what my thinking was to solve towards this problem. Like suppose I need to solve every problem or basically most of the problems uh, that are in the arc. Like humans can solve completely like 100% basic human average human average intelligent human can solve all the problems given sufficient amount of power, like pretty quickly. So I was thinking is if we want to develop a system that is able to solve the arc, then we need to like make the machine as us humans think. What we do is we first of all look at the problem, right? Like we first of all look at the problem and see what is the change in input and output. First we see that what is the change basically. So we see that shape is not changed, shape of everything is same. What changing is the color is changing, like every color is given the numbers, like green is given 2, green is given 3. So what is happening in this task is 2 is changing, the color green is changing into something different, and it is changing in three different colors. Now we are thinking step by step, like what is the change, where is the change, then why the change is done, I mean why only this particular thing, this thing and this thing is changed to this orange color and not all the orange color, or why this thing is then this are changed to blue, and why. So we, when approaching a problem, suppose how the baby thinks, like when we are learning some stuff, suppose we want to make a system which is learning, right? So suppose we want to make a system similarly, like in that paper on the measure of intelligence, it is said that if we are able to develop a system which is like which is generalizing, which has general intelligence, broad general intelligence, then the benchmark for the comparing that system should be humans. Like we humans are like intelligent, right? And we should be the benchmark for evaluating that system. So if you want to develop the system, let's think how we can produce the system which thinks like a human. So what I was thinking, I could be totally wrong. And the way I am thinking could be totally incorrect, or some of it might be correct, some of it might be incorrect. But this is my understanding. If you want to make a machine which thinks like a machine, thinks like a human, what we need to do is, you know, psychologically, like human babies which are of 2 to 3 years, like 3 years, they grasp things like so strongly. They grasp input and like they learn things pretty quickly, and they learn lots of things at that age. So what I was thinking, like, how do they learn that? How do they learn things at that minute, like so very little age? So first of all, what they do is observe. Like observe in the sense, machine cannot observe, like it does not have eyes. Observe in the sense, find out what patterns are present in that particular system. Suppose we are totally focused right now on solving the arc we are seeing currently on the screen. Suppose as a baby or as a machine, I am looking at this grid, correct? So what first I will do is, I will take these 4 inputs. Okay, I will pass them in a machine to, like, yes, machine, take these 4 inputs. I want, what is the pattern in this, what is the size, what is the change. So what I was thinking was, first of all, categorize the problems in property. There are two things associated with this task. First, what properties do the input grid and output grid present? And second, what method? Properties and method. So I had listed down some of the properties which could be present in, like, the here. Suppose, like, what is the unique count of colors? Like suppose in is the here black and green. We don't know black is background for evaluation tasks. So also we need to like specify. We need to identify background as the logically, like, what I was thinking was the color with maximum grids, the maximum count, we will consider that color as background, and then we will solve the particular problem. So maximum count is black for this particular task, so we will consider black as background. Then we come to green. So green, so unique count of colors is 2, black and green. Here unique count of colors is 4, 1, 2, 3, 4. And okay, first we basically note this, the size of the grid is this same. Okay, then what is the count of colors apart from background? The count of colors is same because shape is not changed, correct? Also size is not changed. So what we think is, now suppose uh, suppose here is the color change and we apply DFS from this point. What we will get is, we will get this structure. Okay, this structure. By applying DFS at every single point, we will get unique structures. 1, 2, 3, 4, 5, 6, 7, 8. 8 structures basically, right? Now we have 8 structures which are turned into different colors, and we don't know why. Now we have 8 structures from the machine. By doing DFS, depth first search, we have 8 structures. We have 8 structures. Basically, what I mean is, we have coordinates of particular block of that structure which are connected. Like suppose this is 4 cross 4 block, 4 cross 4, then 5 cross 4, 6 cross 4, 5 cross 5. We have this in a list. Okay, now what, from that list we want to find why this patterns, and this pattern is turned to orange color, and why this is turned to blue. So what we'll do, we again categorize them into into different lists. These two will come in one, this two will come in one, this three will come in one, and this two three will come in one. Now we have three different lists, one with orange color coordinates, one with blue, and one with pink. Now what we want to do is, what we want to do is find the pattern in these lists, right? Why we want to find orange and the elements in or list of orange, what similarity is between them, or what similarity is between these two patterns, or what is different in these two patterns from other two patterns. This we need to find. So for this, like, how do we find this? Like, computer cannot visualize, like it cannot visualize like this is not a like part of a square, or this is like this line is from middle, not from any corner, or this also line is from middle, not from any corner. Computer cannot visualize this. It has to find out by doing some graph methods that this line is from middle, this line is from middle, and this line is from middle, which makes these two different from other two. The computer needs to do this by traversing graph. And and thing apart from this is, we won't be doing the same thing for every problem. Like suppose here is another task. We won't be making the list of blue and orange here and what is happening. We won't be making it in this task. What this is doing is, this is just a pyramid. We will do attach blue like this, blue here, then again orange here, then again blue small, then again orange, then blue. This will be the answer. But finding the pattern in this between these two by traversing graph, and what method we use for traversing is completely different from the one we looked at previously. So but as we don't know what traversing method do we need to use for that particular problem set, we need to use every method of traversing we have for every problem set to find the specific set of rules. As we machine cannot like say by itself, like we can't use a DFS here, we should not use DFS. Machine doesn't know. We know, because our brain has that like intelligence to not. There is no need of separating this. There is just pyramid of alternate blue and orange colors. We know this, but computer doesn't know. But and it has to find pattern. Like it has. We want ultimate goal is to return the function which takes input at this as this, and returns the desired output. And this function will be developed from these two tasks given, only these two tasks given. And developing that function is what counts as intelligence. So developing that function in this arc task is our task. So how can we do this? Okay, I will think about it. So you basically got the understanding of what is arc and what we need to solve. So I will think about this and we will get back to you. This was the first test stream. I will be back tomorrow again. I will think about it today. It was like half an hour stream. Pretty good. Will be good. Let's bye. See you tomorrow.